So that's what the white word is.
This is so you can keep up with, this is kind of a guided notes kind of thing, because students struggle with this.
Yeah, I'm confused. I'm confused. You said there was no graphs.
No, I didn't.
Yes, you did.
No.
You said we were pretty much done with the graphs.
Oh, I lied.
Yeah, you did.
Y'all telling me y'all
Science tangent today. Oh.
Oh, you've already lost me. I'm confused. What are they?
Oh my gosh, I haven't done anything. So you can, I would just do my notes on here if it was me, but that's up to you. Yeah. Or on the front, I mean, it doesn't matter. All right, come, huh?
Oh, they showed it. We're coding. We're coding.
I don't remember last semester as much as I remember last year them struggling with it. I don't know that last semester, the parent graphs not so much. All right, I want you to notice a couple of things. Excuse me, and we're going to talk about why. Notice on your graphs the way the axes are numbered and the way that they go is a little different than what you're used to. If you look across on the x-axis, they're going by pies, right? We generally go by a half a pi, and if you think about the unit circle, it makes sense why. And they've got it going up to 5 and down to -5 on your y-axis, okay? So I'm going, hi. Did y'all struggle with graphing trig functions last semester?
I think it was probably just harder than the unit circle.
Yeah.
But,
Oh, yeah. All right, let's start with sine. So for sine, not sin, my parent function is sine x. Okay? That's your parent function. Yeah, no, go ahead. I'm going to be setting up my graph here. Mine's going to look just a little different because I don't do quite as many tick marks in between. So. I want to take this out to 2 pi on either side. So notice if I've got pi over 2 and then pi, what should the next one be? 3 pi over 2. What should the next one? 2 pi. Where am I getting these values? Or where have you seen them in the unit circle, right? Every half pi here. Yes. No. Oh, it's happening, buddy. My hope is because we've really been hitting that unit circle hard that this is going to make a little more sense to you. Oh, you're having another quiz tomorrow? Yeah, we're going to keep having them.
I'm not going to be here.
Same thing.
I've got a game against
No, don't do that. Probably be no calculator this time.
I didn't use it the last one. I was just guessing.
All right. We'll talk more about that in just a minute. But not. Right. Yeah. No. Ask your question. Now, if my function is sine of x, that means every x I'm plugging into, I'm taking the sine of. So I want you to think with me for just a minute. Think about it like a t-chart. If I plug in 0, what is the sine of 0? 0. Everybody agree? Sine of 0. So 0, 0 is a point on my graph. And now, let's only pick the easy ones. What are the easy coordinates? Yeah. What are the easy places on the unit circle to find coordinates? Every half pi, right? So 0, pi over 2. Ooh, convenient. Pi. Uh-oh, there it is again. 3 pi over 2 down at the bottom. You see where I'm going with this? Those are easy coordinates to find. No? They're not, because we're saying like the coordinates like 0, 1 or 1, 0. They're easiest. If I go in between here, those are nasty numbers to graph. But if I stay at every half pi, they're nice whole 0 or 1. Okay, watch. At pi over 2, what am I graphing? I'm graphing sine of x, right? So think about like a t-chart. If I plug in pi over 2, what is the sine of pi over 2?
-1.
Oh my goodness, don't just guess. Okay, what is the sine if I'm at pi over 2? It's 1. I'm sorry. I was distracted by those equals. 0, negative 1,
He's the
1.
one you answer. That's what I'm guessing.
Because of the coordinates. That's exactly right. So this is like what you were doing on the back, but we're finding those values, right? So sine of pi over 2 is 1. What is the sine of pi? Oh my gosh, 0. What? Woo!
Start off up. That's probably good. You almost graded our project?
Okay, loop it back around to 2 pi. What's my sine at 2 pi? 0. Let's go the other direction. So now, instead of going up, negative pi over 2, what's the sign?
1, 0, -1.
Just keep saying random numbers, you'll get there eventually. Goodness gracious, -1. What's the sign of negative pi?
1.
I hope you are seeing the pattern here. What's the sign of negative 3 pi over 2?
There it is.
Not 3 pi over 2, but negative 3 pi over 2. So we're going the other direction. The sign of negative 2 pi.
0. Oh, yeah.
Now look at this nice sine curve. Not a squiggle. Oh, we got a lot more than this.
So what were we
Okay. This is sine of it. Oh, we're transforming them. This is just a pain. All right. Domain here. Domain is left to right. That's my x. What is the domain? Negative infinity to infinity. There's no restriction. Do we agree? How about the range? -1 to 1. That's my bottom up, right? But it's inclusive. Sine never goes below -1. It never goes above +1. These are very, very important as we start analyzing some different things with these trig functions, that you understand the domain associated here in the range. Yeah. So, well, it's actually every pi. All right. No, those are maxes and min. All right. So I'm going to teach you some new notation. Y'all stay with me, okay?
My head hurts. I was confessed.
All right.
Can we just start again?
This bit class is stressing me out, Mr. Heath.
The faces, or whatever. I don't even know. I'm telling you, it's not brain yet. This McGee, it's a Monday. We can't do
He
this.
just called you mistake.
That's a compliment, honestly.
Looking at this, the x-intercepts. Now, Dozier told us he sees that the x-intercepts are happening every pi, and we can all see that, right? The question is, how am I going to write that? I'm going to say, not since, I'm going to say x-intercepts. Okay, but
At every whole.
at every whole pi, how can I say that?
Technically, pi is a whole.
I'm going to say x equals, are y'all ready for this? K pi,
Oh yeah, put a K on it.
but I'm going to say where K is a member of the integer
As
family.
a member of.
Okay. That's not an E, that's like a C with a line through it.
Alright,
So this
first
is mathematic notation, okay? I'll never forget the class. Okay. This is mathematical notation. This is a mathematical sentence. Just like, remember the first time you saw in behavior as X approaches, da da da, and there's no, yeah. Okay. Huh? What? The Z means integer. This means is a member of integer thing. Or is an integer. But I'm not saying pi is, I'm defining K to be an integer. That means every time any integer you put in for K, and with a pi on the end, that's an x-intercept. Name an integer. 7. 7 pi is an x-intercept. Name an integer.
8.
8 pi is an x-intercept. That's right. Right. But I didn't say K pi was an integer. I said K is an integer. So I started picking because I know about the unit circle, and this is going to be typical for sine and cosine and tangent. Every 90-degree mark, you can keep going around. This sine, cosine, tangent. Yes, sine is the y. Sine is the y. How about y-intercept? How about asymptotes? Oh. Well, there are none here, right? Right. Now, what is the amplitude? The amplitude
Hey.
all right, listen, the amplitude, to find the amplitude algebraically, I'm going to show you how to find it from the equation. But amp is always max minus min divided by 2. You can look at the graph and it goes up but to 1, but that's when it's centered at 0, right? Divided by 2. Right. No. No. What's the highest it goes, Dozier? What's the lowest it goes? No. What's the lowest it goes? -1.
There he is.
Some days I need to quit.
Yeah. I see.
All right.
I'm ready already. So.
Please, you
Check out
the rest of us ain't taking it.
All right.
I might drop
The good thing is this is way harder than calculus. Okay. Amplitude is 1. Max minus min divided by 2, or the height from the x-axis as long as it's centered in the x-axis. But this is amplitude. Okay? Period. Now here's what period means. I can't believe y'all have not done this in chemistry or anything. Okay, so period is how long it takes it to complete one whole cycle before it starts repeating. So look at the graph and see if you can tell me what 2 pi, right? Because I go 0 up, 0 down, 0, and then I'm back to up, 0, down, 0, up. Yes, it's how far it takes it to do a complete cycle. So if you look, I've got one complete cycle over the course of 2 pi. Logan. Period is how long it takes it to make one complete cycle. What? That's some pictures.
Yeah.
All right, now listen. What's going to impact? Think in terms of transformations. Logan, this question's for you. What transformation would impact amplitude? What kind of stretch? Vertical stretch or shrink. That's exactly right. What kind of transformation would impact the period?
Horizontal stretch.
Or
Yeah.
Logan and Dozier. All right, 2 pi. There we go. All right, let's look. Go down. We're going to talk about transformations for a minute. What happens when we start transforming this parent graph? It changes. Let me show you what a transformed sine graph looks like. And let's talk about what everything does. Okay? All right. Y'all said.
You gonna eat me alive yet? Oh, really?
Y'all said.
That was not meant to be like that. I'm listening.
Tell me what impacts amplitude again.
Vertical.
Vertical stretch. Okay, you got this. A vertical stretch or shrink. Which variable in this equation deals with my vertical stretch or shrink?
Hey.
Vertical. Somebody said it. No, somebody said it first. Hey. Y'all, everybody is just hollering random letters right now.
C.
The absolute value of A is the amplitude of your graph. Since there was no A in the one before in your parent graph, it's really a 1. That's why the
Where do we
amplitude
write
is
that
1.
down at the bottom?
Okay, yep. Mm-hmm.
Oh, there's actually a place for it.
There's actually, these are what we call guided notes. They guide you with what you need to write.
I wish we had these more.
All right. That's your vertical stretch or shrink, and that is now representing your amplitude, but I want you to understand why, because transformations still apply, but that's what it's impacting is your high and your low. All right. Now, we said the vertical, turn around, Logan, the vertical stretch or shrink is your amplitude. So what impacts your period? The B, which is your horizontal stretch or shrink, but it's a little bit different. What'd I do? Did I? I don't even realize I do it. I don't know. Okay. All right. Is that what I did? Okay. So we take the parent period, which is 2 pi, and divide it by that absolute value of B, and that's going to give me my new period. These are the hardest 2 things to remember about sine and cosine. Nobody does.
No test on this one.
I'm gonna come back and touch it.
Hey, we don't have one of those cumulative tests on this one.
Yeah.
Well, I'm gonna try it.
I know
I
how
believe
he
my
did
boy
it.
Smitty. I believe he's got hard.
I know how he did it.
Kid got 0.
Horizontal, just so you remember, horizontal shifts. Your H. What's it say? Phase shift, horizontal. This is your H. And remember, H is always my opposite. So if it's negative, it moves to the right. If it's positive, it moves to the left. If it's missing, it stays put. It doesn't move at all. Yeah. don't know. I can't do it. You can't put me on spot and make me do it because then I can't think about it. Because the vertical shifts, that's your K. Positive is up, negative is down. I don't want to because if y'all are doing it here. Nothing. He said nothing. He said nothing. Okay. We still got to make it through cosine tangent.
Can we do this one day each week? We do one of these? Let it, yeah, can we do it?
No.
I need it. I'm like spazzing out of it.
If we take a brain break, y'all will come back and let me finish my 2 graphs?
Yes.
Promise?
Thank She would. She would. No, Hannah wanted to. Hannah would.
I'm gonna call her in there. Let's be like,
No.
All right. Cosine, here we go.
Yeah.
we can. Don't trip over that. Cosine of 0. What's the cosine of 0?
1.
Max? What is it? 1. No. Yes. Cosine of 0 is 1. What's the cosine of pi over 2? 0. What's the cosine of pi? -1. Cosine of 3 pi over 2. I bet you can guess from here. 0. Do you see the pattern? It's clicking. Cosine of pi is -1. Remember, it's your x value. Yeah. No, we go up to. Logan, get out of my desk.
I can't move.
Logan, get out of my desk. Logan!
I can't move. Don't.
Negative infinity to infinity. How about the. Okay.
-1. That's your kick set? Yeah, that's like the linebacker.
Oh, welcome back. I was gonna get the door.
Ready?
We've had short lines.
Yeah. How about range?
I thought walking like 5, 7, 5.
-1, 1. This one, a lot of these are going to repeat. With the exception of the x-intercepts. Gross. Yeah, because these are different. What's happening here? It's not every whole pi. I mean, the space between them is the same. Every half pi. So this time, here's what I'm going to say. I'm going to say start at pi over 2. Right here. How much space is in between? 1 whole pi, right? So this time, instead of saying every k pi, I'm going to say every pi over 2 plus k pi. And I'm going to define k as being for x-intercept. Okay, so that means that pi over 2, and then if I add or subtract any whole number of pi, I'll get to another one. So if I'm here, right, if I added 2 pi, that would put me, there's 1, there's 2, that would put me there. Any whole number of pi that I add to it will put me back in the intercept. Because k pi would be every whole pi. It's not every whole pi, it's every half. It starts at half pi and then goes every pi. What do you mean the lines? Y-intercept. Zero, 1, or 1. How about asymptotes? None. Yeah. Go. No. Well, as you shift, yeah. No. Amplitude's still 1. And period's still the same. Now. What? Yes. Huh? Yes, transformations. All right, so transformations. Your transformations, I'm going to write this equation for you here. Cosine x minus h. Everything from the sine section of transformations, copy it over for the cosine section. It's exactly the same. Absolute value of a is still your amplitude. Your b is 2 pi over b is still your period. And your h and k are still your vertical and your horizontal. Absolute value of a. Okay. Plus is up. Plus k is up. Minus k is up. English. Yeah. Tangent is the toughest one. Are y'all ready for this? There are asymptotes.
Still 0 though.
All right. Same. Yep. Not for tangent, but for cosine. Yes.
Are we done after this?
That's for tangent. All right, y'all ready? Looking at your circle or thinking about your circle, huh? Ask one question. Oh, because I'm looking somewhere else first. That's the right thing. What's special about tangents as you look around your circle? They're the only ones that have an undefined point, right? Undefined is where I'm going to put my asymptote. So tell me this. Where on your unit circle am I being undefined for tangent? The tangent, look at tangent. Where is it undefined? Pi over 2 and 3 pi over 2. Where else do you think it might be? The negative, that's right. So negative pi over 2. So they're happening actually every pi distance apart. You see that? Well, actually, you're right because tangent has a different period than sine and cosine. All right, so let's see. Dozier, what's the tangent of 0? Now let me ask you this. As you look at your unit circle, and here, this is how I remember it. As you look at your unit circle, right, if you start at 0 and you get closer to pi over 2 up top, is your tangent value, square root of 3 over 3, 1, square root of 3, is it getting bigger or smaller? It's getting bigger, right? So this side approaches this asymptote this way and then approaches downward here. It almost looks like a cubic in the middle. And it is going to keep this pattern all the way through. Yep. Because this one has a different period than the All right.
We can just number like on L right there.
Yeah, we're not gonna
Is that what he does?
He's like, all right. Here we go.
Was the hardest.
That's what he does every time before he talks
But
about
they did it.
we're like questions. Oh,
Yeah, yeah. They this is
Y'all
the
remember
lowest
that?
set. But they didn't do what I told them. Okay, me and
So, he's like, I just said that.
All right, let me say it another way.
Okay.
Yeah.
Okay, wait. I do that sometimes. Sometimes we just don't know the answer. We have to think about it.
Now, how are you going to teach it if you don't even know?
There are some things that are hard that I have to think through.
Yeah. So you have to assume based on question
I
3A.
promise you can.
Yeah. Yeah. One part 1A3.
What up, Miguel?
All right. What's the domain?
Negative infinity.
No, you're like
But you're right. You're right. Negative infinity, but skipping all the asymptotes, right? So now the question is, how am I going to say that? Not every half pi, but starting at half pi. So what I do is instead of saying what x can be for my domain, I say what x can't be. I say x cannot be. And I'm going to do this the same way I did those x-intercepts before. Pi over 2 plus k pi, where k is an integer, right? That's where my asymptotes are happening. Here. Skip it, go a pi. Skip a pi. You see what I'm saying? Say that again. No, this only works because there's so many repeating like this. Technically, what you should do is say x is a real number, except it can't be. But I don't make you do all that. All right, range. Yep. Range is all real numbers. No problem there. So the x-intercept is what we did what? What did we do first? Okay, so it's every single whole pi. So yes, you're exactly right. It's x equals k pi, where k is an integer. How about y-intercept? These and the reciprocals. All right. Asymptotes. That's exactly right, Miguel. Take the domain and don't put the not equals, put the equals.
That, I'm so proud of you. That was so good.
So here your asymptotes are going to be x equals instead of not equals, and it's going to be everything that you left out of the domain. Well, we started there because we needed it to happen at all the half pi's, because they're not happening at whole pi's, they're happening at pi over 2, 3 pi over 2. So we needed to start off center. Go ahead. Then you could just say k pi, because every whole, it would be 1 pi, 2 pi, 3 pi, 4 pi. Right. So your amplitude here actually is undefined. Tangent cannot have an amplitude because it can't have a max and it can't have a min since it goes on forever and ever. period's 1 pi. Your period's 2 pi. All right, for your transformations. What am I doing?
Stop that. We don't eat the other stuff.
Pi.
Yeah. Much love, buddy. You got a flight.
What's the amplitude?
Same thing.
Undefined. That's right. It doesn't matter how I stretch or shrink. I'm still not going to have a max or a min. You've been squinting a lot, Emery. You okay? What's the period? Close. Pi over the absolute value of B. The same thing, you take the parent and you divide it by the absolute value. Because, your tangent, it doesn't span as much. It repeats every pi.
You just take your period.
All right. H and K, copy the same thing over. Because if you look at the graph, it does this whole cycle in 1 pi instead of 2 pi, and then it repeats.
Okay, hold on for this too.
All right, take out your calculators for a second. I want you to look at. So y equals. We'll start with tangent since we just wrapped that one up.
Same thing.
Classic. Mine.
13. What about weighing symbol?
I mean, I don't care. I'll do that.
Yes.
I'm not old.
Yeah, let's go dark. Let's go
Hey,
dark.
one more.
No, we're not putting them all off. All right. Are we all there? All right, you're in radians. Hit y equals. Hit tan. Do you see the tangent button on your calculator? Tan x. Hit tan and then the x button. And then go zoom 7.
Yeah, over there it is, go. Yo, it does it for me.
All right. Everybody. Can everybody get the graph on their calculator? The zoom 7, by the way, takes you out negative 2 pi to 2 pi, and I think it goes 5 to negative 5. Do the same thing and check out your sine and cosine. Make sure you can see everything. Make sure everything will graph correctly for you because we're going to use those graphs to help us with some stuff. Yeah.
So we done that?
I'm going to do a couple, but let me just see if you understand really quickly before I finish up, because we still got 15 minutes. Say
You
again?
watching American Idol?
Period is what? Oh, not yet, but we will. We'll be doing inverse and.
The 15-year-old dude, he's real good. You hear him sing, what's his name? God's Country. God's Country.
What's the amplitude of this one?
Yeah, it's really good.
without graphing it.
All of them are really good. I want to watch the.
Hush. How do you know? How do you know the amplitude here? There's nothing in front. Amplitude is your A in front. The amplitude is 1. What is your period?
Two pi over 4.
I over 2.
What has happened? What has happened here? Is it happening in a shorter span or a bigger span?
Bigger.
Think about this smaller. Listen what this means. All right, what's the sign of 0?
How are we supposed to know?
If this is my parent graph, right? I go all the way out. This is 2 pi. Instead of it taking that long to make one complete cycle, now it's making a complete cycle in a half of a pi, which happens right here. That means now it's doing that. Do you see the difference there in what's happened? The amplitude is the same, but the period has just shrunk it all the way in. It's a horizontal shrink, which makes sense because this is my B. It's a shrink of a 4. Do you see that?
Why do you have to do it?
The one hooked to the B, hooked to the X, that's your horizontal shrink or stretch. That's a horizontal. Remember, it's opposite because it's horizontal. So it's a horizontal shrink, which means it takes these and goes whoop, and smushes it in, right? So instead of it making a loop over this course, it's shrunk in and it has to make its whole entire cycle in a quarter as much. Okay, let me show you another one. What's the amplitude? What does that mean as far as my graph goes? That's exactly right. So it's a vertical stretch, right? So that means it goes up 3.5, down to 3.5, but everything else is still taking 2 pi to make a cycle, right? This one's cosine, so it starts here, so it's still doing, but it's really stretched at this point. It's really stretched out in doing it. Does that make sense? No? So amplitude is just how high up it reaches. It reaches up to 3.5 instead of being the parent graph like this. How about the period on this one? It's still 2 pi. It hasn't changed, right? Because the B in front would change the period. It's 5. Remember, it's absolute value. Now, this one also has something else going on. What is it? It flips, right? It flips because of this negative. So instead of starting up here, it's going to start down here and go through. It's got an amplitude of 5, so it's really tall, right? It's really stretched out. How long does it take it to make a period? What's the period? Remember, it's 2 pi divided by the B. It flips it. It's that reflection. So what's the mid-period? 6 pi. That means it's really stretched out, right? So whereas it did take this far to make it up to a height of its maximum, it's probably going to go this far before it hits its maximum, right? It's really stretched out. Does that make sense? Y'all see how these numbers are impacting my sine and cosine waves? One more. Flip 1 right? So it's flipped upside down. What's the amplitude? 2, so it's twice as tall, right? What's the period? Two pi divided by 4/3, so it's 2 pi times 3/4, which is what? 3 pi over 2. Which that's how long it takes it to make one complete cycle. Does that make sense? We'll play with these and work with these tomorrow. I really don't